It's a clear and cool even. It feels like that. Okay, so we were discussing the topic called as a periodic table, that is called a modern periodic table, and we have covered the fundamental part which is needed for this one, and further also we have delivered what is the modern periodic table, as well as we also delivered that is the electronic configuration in modern periodic table. That is actually what we are discussing as of now. जो हम लोग already discuss कर रहे हैं. That is what is meant by electronic configuration in modern periodic table. How is the place of elevated periodic table is decided by its electronic configuration. How the conceptual electronic configuration has the impact while developing this periodic table. That's what we were discussing. Out of that, the point number one is we are here with this electronic configuration in a group. Now, how group and electronic configuration are related with each other, that is what we are seeing. The second topic is that how the electronic configuration and periods are related with each other, that is also what we are seeing. The third one is that is electronic configuration and blocks, that is what we have to discuss. So let's come here. That is, you can say electronic configuration model periodic. Out of that, first is nothing but you can say electronic configuration and group. That's what we have seen first. Second, that is electronic configuration and period. And the third one is nothing but electronic configuration and group period. You can say block. Block. That is, you can say S, P, D, and F block elements. This is what we have to say. Block S, P, D, F block elements. So these are the topic what we are discussing. We have to discuss over here. So we have seen this one. Now, already we have seen the rough diagram of this periodic table. So this is a rough diagram of periodic table you can have. We have this one. So this is okay. This is wrongly drawn. So first, second, 3 to 12 and 13 to 18. This is what we can say. So this is electronic configuration. This is a rough diagram what we can have for the periodic table. This is first, second, third. This is fourth, fifth, sixth, and seventh period. Fourth, fifth, sixth, and seventh periods. That is what we can say. So this is now the thing is that इलेक्ट्रॉनिक कॉन्फ़िगरेशन ग्रुप ऑलरेडी हमने डिस्कस किया था. इलेक्ट्रॉनिक कॉन्फ़िगरेशन एंड पीरियड हम लोग डिस्कस कर रहे थे करके लेक्चर में. व्हाई फर्स्ट पीरियड, मतलब सी दिस इज द फर्स्ट पीरियड. सो फर्स्ट पीरियड हैज ओनली टू एलिमेंट्स. So we can say first period has only two elements. Then second and third element have 8 elements each. Then fourth and second, third, fourth and fifth has even you can say sixth one. Fourth, fifth has 18 elements each. Then sixth one has 32 elements, and seventh has still incomplete. So this is the electronic configuration what we can have here. So please, when we discuss the electronic configuration of period, first period has 2 elements. Why it is we have discussed yesterday, because its electronic configuration starts with hydrogen 1s, and s has the capacity of maximum 2 electrons, and that's why it can have only 2 elements. Second starts with lithium, that is 2s, or 2s has 2s and 2p. These are the two subcells. So s has the capacity of 2 and p has the capacity of 6. Total 8 हो सकते हैं, and that's why second has 8 elements. Third has also third starts with 3s. 3s has 3s, 3p, and 3d. But d is you can say 3d. That is filled after 4s. So with the 4s, next group next period has to start, and that's only 3s and 3p is filled. That again consists of 8 elements. So second and third has only 8 elements each. When we talk about 4 and 5, 4 and 5 has 18 elements each, because this one starts with 4s1. So 4s, 4p, and 3d. These are the subsets which are filled. So that's why it has, you can say, 18 elements each. 5 also starts with 5s. So it has 5s, 5p, and 4d completely filled. So S has 2, P has 6, and D has 10 elements. That's why it has 18 elements. So group 5th and 5 has 18 elements each because we have the according electronic configuration starts and ends with that. When we talk about 6 has S orbital has 2 elements, G has 10, and this P has 6, so total 18 elements. But there is this is the extra added group which is perpendicular to this one. You can separate one. So that belongs to third period and third group and sixth period. Third group and sixth period. So these are the 14 elements are added in this one. So this total completely 14 elements are filled. This 14 and earlier 18 one, that comes to 32 elements are present here in sixth one. Because F subcell is there also. When we talk about 7 is still incomplete. It has 18 elements because we have to discover the elements. But if we include the natural and artificial, then 100% it is filled. But if we remove them, then it is as of now still incomplete. So this is what we have electronic configuration of it. So once we know the electronic configuration, once we understood electronic configuration, then we can predict why that particular group has this much element. पहले में 2 ही की हुआ है, दूसरे में 8 की हुआ है, तीसरे में 8 की हुआ है, फोर्थ और फिफ्थ में 18 की हुआ है, सिक्स्थ में 32 की हुआ है, और सेवंथ अभी तक इनकम्प्लीट है, वो उतने एलिमेंट नहीं, जगह है वहां पे. So this is the electronic configuration period what we have seen, and that is the pressure group here. ठीक है. Now we have to discuss the electronic configuration and the blocks. Electronic configuration and blocks. Okay. So also you don't have any doubt regarding this electronic configuration and this period. Electronic configuration and block. Generally, हम अच्छी तरह जानते हैं. This periodic table consists of all these elements called as S block elements, or these elements called D block element, or called as P block element, and all here are called as F block elements. So S, P, D, F block element. This is a classification. So S, P, D, F. These are called as subcells, and this is the rough classification of we can see here. So S block consists of group first and second. So group first element and group second elements are called as S block element. Group 13 to 12 consists of D block elements. Group 13 to 18 called as a P block elements, and here is the separate series below this periodic table called as the F block elements. So this classification of elements on the basis of block S, P, D, F block is again depends upon the electronic configuration. So we can have the generalized definition for all of them. We can have the generalized definition for all of them. What we see or what we discuss is that these are the elements whose last added electrons enter into S subcell. These are the elements whose last added electron enters into S subcell. That's why they are called as S block elements. These are the elements whose last electron is added into D block, and that's why they are called D block elements. These are the elements whose last added electron enter into P subcell, and that's why they are called as P block elements. These are the elements whose last electron enter into F subcell. That's why they are called F block elements. So easy, so simple. So we can have the example for each of them. सब के लिए देख सकते हैं. इसमें से कोई भी एक एलिमेंट लेते हैं. चलो हम लोग पोटेशियम लेते हैं. That is potassium 19. Potassium 19. Let's have the electronic configuration of potassium. That is, you can have 1s2, we can have 2s2, 2p6, 3s2, 3p6, 4s1. See, this is the electronic configuration. 2, 2, 4, 4, 6, 10, 10 or 18 or 19. So this is the last electronic configuration. 19 electrons are done. So the potassium elements which belong to this fourth period and first group, it has last added electron in S subcell, 4s. So that's why this element is called as an S block element. The element whose last added electron enter into subcell are called as an S block element. All first group element and second group element belongs to this one. So take an example of calcium. Calcium 20. Calcium 20. Again, this is the electronic configuration up to this 3s is of argon. So I can write this argon as it is. So instead of this electronic configuration, I can write argon because argon का ये होता है 18 तक. इसके आगे this is 4s जिसके अंदर 2 आएंगे. कैल्शियम में 20 है. यहाँ पे 18 हो गए. And this is 2, 20. So calcium 20 has this electronic configuration again. Calcium 20 has this electronic configuration where we can see this argon 18. This is the same electronic configuration as like argon, and comma this is 4s2. So again calcium which is present here again. Calcium यहाँ पे present होता है. This is calcium and this is potassium. So we can say Potassium has last electron in S subshell, whereas calcium is also has last electron in S subshell, and that's why both elements are known as S block elements. So we can have this example for this S block element. D में से कोई भी एक एग्जांपल ले सकते हैं हम लोग, से फॉर एग्जांपल हम लोग मतलब हमने कही है स्कैंडियम किया है, क्रोमियम किया है, कई सारे किया है. तो स्कैंडियम इज द फर्स्ट एलिमेंट 21. सो अगेन इलेक्ट्रॉनिक कॉन्फ़िगरेशन इज 1. चलो स्कैंडियम में भी वही होगा. आर्गन का इलेक्ट्रॉनिक कॉन्फ़िगरेशन आर्गन हियर इज अप टू 18. देन उसके बाद आता है 4s2 and this is 3d1. So this is the scandium. So scandium is the element whose last electron is added into D subcell, and that's why this must be called as a D block element. This called as a D block element. ठीक है? So any of the element from this one, जैसे कि scandium के नीचे आते हैं हम लोग, तो we can have here yttrium, which is again electron here in 41. उसके नीचे हम लोग आते हैं lanthanum, again उसके अंदर 5d1. उसके नीचे आते हैं हम लोग, you can say 6d1. So this is the electronic configuration what we can have here. तो ये electronic configuration हम लोग उसके अंदर मिलता है. So in that sense you can say all elements present here in D block elements, all elements present here in D block element has the last added electron into D, D, and that's why they are called D block elements. So any element you can take it from here. Then take right from here. कोई भी element यहाँ से लेते हैं हम लोग. Say suppose it's aluminum. So aluminum has atomic number 13. So this is 1s2, 2s2, 2p6, 3s2, and 3p1. Thus, दोबारा और एक 13. So this is the last. So if we take the example of aluminum, aluminum has last electron which is present in p subcell. Aluminum has last electron which is present in p subcell, and that's why it is called as a p block element. You can take any element from this one, any element from here, this category that has last electron added into the P1, or that's why they are called as P block elements. Or we can have this F block elements. F block का अभी तक हमने कोई example नहीं देखा था, but we need to have the example of F block. So यहाँ पे लेते हैं हम लोग ये F block element. चलो हम लोग लेते हैं lanthanide, which is a 57, atomic number 57. So we can have lanthanide 57. We have tried the electronic configuration up to 57 electrons. So we'll be having 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Okay, 3d10. Then 3d के बाद 4p6, 4p6. Then 5s2. 2 10 10 10 20 30 30 और ये 40. We have to have a sequence. That is we'll have sequence 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 6s, 6p. So देखिए we can have the sequence. मतलब need not to learn all this one. So you can say 4p के बाद 4p के बाद 5s आता है, 5s के बाद 4d आएगा. So we can have 4d10, 4d10, 4d के बाद वापस 5p आएगा, 5p6, 5p के बाद 6s आएगा, 6s2, and then 4f आएगा. So अभी कितने इलेक्ट्रॉन बचे उसके हिसाब से देखते हैं हम लोग. So here are the 10 electrons. ये 10, ये 30 और ये 10 40, ये 48 और ये 8 48 56, और here is the one electron, that is you can say 51. So this is the diagram how we can write the sequence of the energy level. See, ये learn करने की जरूरत नहीं है. learn करने जाएंगे तो बहुत difficult जाएगा, because it will do a lot of efforts to learn. So just I think so camera is a bit blurred. The movement was too much, so I think so it's kind of blur. So as I stated, this is the sequence. What we need not to remember. We can just make this diagram and we can make the sequence, and this is the sequence. How we can write the electronic configuration for any of the elements. Just we have to follow the sequence. So if we follow the sequence, then fill the electrons according to its capacity. तो हमने हर एक कैपेसिटी के हिसाब से इलेक्ट्रॉन भर दिए. 4f1 में आया था लास्ट इलेक्ट्रॉन, that is 57. So that means this is the element whose last electron occurs into F cell, F subcell. This is the element whose last electron occurs into F subcell, and that's why this element is called as your, you can say, lanthanum or lanthanide, and that is called as your F block element. All elements present here, even actinide has atomic number 89, uranium, thorium, einsteinium, technetium. There are many elements whose last electron occurs into F subcell, and that's why they are called F block elements. So simply what I stated, the classification of elements on the basis of electronic configuration as S block element, D block element, P block element, F block element is due to the last electron occurs into that respective subcell. So all these are the elements whose last electron occurs in S subcell. All these are the elements whose last electron occurs into D subcell. All these are the elements whose last electron occurs in, you can say, P subcell, and all these are the electron whose last electron occurs in this subcell. That is what we can see here. Prashant is asking, sir, why did we took orgon? Then, in spite of writing the whole configuration in scandium 20, did not understood. Okay, very good. सबसे पहले प्रशांत मैं आपको थैंक यू कहना चाहूंगा बिकॉज आपने क्वेश्चन फॉरवर्ड किया. मतलब दिस इंटरेक्शन ऑलवेज आई लाइक टू हैव द question answer session, any type of interaction regarding this series. Second thing is that I will answer your question. This is the way how we can write the electronic configuration. This is also called as condensed electronic configuration. Condensed electronic configuration. मतलब प्रशांत का ये सवाल था कि यार यहाँ पे कैल्शियम की बात करो, स्कैंडियम की बात करो, यहाँ पे मैंने आर्गन क्यों लिखा है और उसके बाद फोरिस लिखा है. स्कैंडियम के यहाँ पे आर्गन क्यों लिखा है? See, this is the special group called as 18 group elements. This is the special group, 18 group. And all these elements are called as your inert gases. हम इसी चैप्टर में आगे देखने वाले हैं. मतलब इस टॉपिक के बाद हमारा वही टॉपिक शुरू होगा. All these elements are called as your noble gases, or also called as inert gases. All these 18 group elements. That is, you can see here is the helium, neon, argon, krypton, xenon, radon. All these are the elements. All these elements are called as, you can say, noble gases elements or inert gases. The reason behind that, all these elements, why they are called as noble or inert? Because they do not take part in chemical reaction. They do not take part in chemical reaction. Thing is that why they don't take part in chemical reaction? The reason behind that, according to this theory of electronic configuration and all, these are the elements whose last subcell is completely filled, either duplet or either octet. Helium is the element which has completed duplet, and that's why the element whose outermost shell is completely filled is a stable element. Already हमने देखा था electronic configuration क्या था. तो हमने electronic configuration में देखा था कि the element which is at the center. Yes, Parth, it's मतलब पार्थ का भी क्वेश्चन आया, उसका भी आंसर दूंगा बाद में. But when we talk about these elements are the elements whose last subcell is completely filled, and the elements whose last subcell is completely filled attain the stability. They becomes more stable. ये किस तरीके से है ना कि मतलब कोई भी element reactive क्यों होता है? Because हमने octet नाम का concept देखते हैं हम लोग, where it states that most of the elements try to complete 8 electrons in its outermost orbits, and that's why they attain the stability by completing that. उस हमारा है कि मानो हम लोग को बहुत भूख लगी है और बहुत भूख लगी है तो हम लोग ज्यादा जहां खाना मिलेगा खाने की कोशिश करेंगे, और वो भी जरा थोड़ा सा जल्दी में खाने की कोशिश करेंगे, है ना. सामने वाला अगर हम कहीं गेस्ट के यहाँ भी जाते हैं और बहुत जल्दी खाते तो उन्हें भी समझ में आएगा कि ये बहुत बंदा भूख लगी हुई है, इसलिए बहुत जल्दी में और स्पीड में खाना खा रहा है. लेकिन मानो हम लोग खाना खा के कहीं किसी गेस्ट के पास जाते हैं और वो वहां पे हमें फोर्स करते हैं कि आपको खाना खाना है, तो शायद हम ना भी कह सकते बिकॉज हम हंग्री नहीं है. we had lunch, whatever is that, and so that's why we are not with the empty stomach. हमारा पेट भरा हुआ है तो ज्यादा खाना नहीं खाएंगे, खाने की कोशिश भी नहीं करेंगे, या थोड़ा सा उतना हारी नहीं दिखाएंगे हम लोग खाने के अंदर, है ना. रेस्टलेसनेस लाइक दैट. तो उसी तरीके से all these elements have completed their octet and duplets. Why any of the element is reactive? Because it's tried to complete 8 electrons. According to one of the theory, एक theory का कहना ये है कि कोई भी element reactive क्यों होता है? Because वो अपने outermost में 8 electron complete करने की कोशिश करता है, और वो इलेक्ट्रॉन अगर उसके ऑलरेडी कंप्लीटेड है तो वो रिएक्टिविटी नहीं दिखाता. सो ऑल दीस एलिमेंट्स आर द नोबल और इनर गैसेस बिकॉज़ देयर ऑक्टेट इज कंप्लीटेड, देयर ड्यूप्लेट इज कंप्लीटेड इन केस ऑफ हीलियम, और बाकी रेस्ट एलिमेंट में 8 इलेक्ट्रॉन कंप्लीट होते हैं, एंड दैट्स व्हाई दे जनरली डू नॉट टेक पार्ट इन केमिकल रिएक्शन. और हम लोग अगर बेसिक लॉ की बात करते हैं, हम मेंडलीव लॉ की बात करते हैं, या फिर हम लोग मोसलेस लॉ की बात करते हैं, तो जो लॉज ऑफ ऑक्टेव्स आता है, या फिर व्हेन ऑल एलिमेंट्स आर पुट अकॉर्डिंग टू इंक्रीजिंग एटॉमिक वेट, या फिर इंक्लूडिंग एटॉमिक नंबर. अभी मॉडर्न पीरियोडिक टेबल के लिए हम लोग तो एटॉमिक नंबर की बात करते हैं, बट सारे थ्योरीज यही कहते हैं when elements are put according to their increasing atomic number, every eighth element has the same property as like first one. So यहाँ से देखेंगे सोडियम, मैग्नीशियम, एल्यूमिनियम, सिलिकॉन, फास्फोरस, आर्गन. आर्गन के बाद वापस एक एलिमेंट ऐसा आता है पोटेशियम जिसके सोडियम की जैसे प्रॉपर्टी है. सो 8 एलिमेंट के बाद मतलब सोडियम से स्टार्ट करते हैं तो सोडियम के बाद 8th एलिमेंट हो जाते हैं और 9th वाला एलिमेंट हैज द सेम प्रॉपर्टी एज लाइक पोटेशियम हैज द सेम प्रॉपर्टी एज लाइक सोडियम. और इसलिए क्लासिफिकेशन भी इस तरीके से किया है. और ये प्रॉपर्टीज डिपेंड करते हैं उनके इलेक्ट्रॉनिक कॉन्फ़िगरेशन के ऊपर. हम ये भी जानते हैं कि सोडियम हैज आउटरमोस्ट इलेक्ट्रॉनिक कॉन्फ़िगरेशन 1s1, पोटेशियम हैज इलेक्ट्रॉनिक कॉन्फ़िगरेशन s1. So that's why they exhibit similar properties, common properties, and that's why they are placed in same group. So ये end point है, किसी भी पीरियड का end point है. तो ऑर्गन पे यहाँ पे इलेक्ट्रॉनिक कॉन्फ़िगरेशन उस जो सेल है उसका खत्म हो जाता है और इसके बाद नेक्स्ट सेल शुरू हो जाता है. सो कहीं भी हमें अगर शॉर्ट फॉर्म में इलेक्ट्रॉनिक कॉन्फ़िगरेशन लिखना है तो किसी भी इसमें से मतलब ये जो थर्ड पीरियड के सारे एलिमेंट है उनका नियॉन के बाद लिखा जाता है, फोर्थ पीरियड के सारे उनका आर्गन के बाद लिखा जाता है, फिफ्थ पीरियड के सारे उनका क्रिप्टॉन के बाद लिखा जाता है और सिक्स्थ पीरियड के उनका ज़ेनॉन के बाद लिखा जाता है, रेडॉन के बाद लिखा जाता है, सो ऑन. सो बिकॉज़ दिस इज द नोबल गैस इलेक्ट्रॉनिक कॉन्फ़िगरेशन जो ऐसा रहेगा वहां तक चेंज नहीं है, उसके आगे के इलेक्ट्रॉन ऐड होता जाएगा. दिस इज द वे हाउ वी राइट अ शॉर्ट वे. कंडेंस इलेक्ट्रॉनिक कॉन्फ़िगरेशन बोला जा सकता है, वो यहाँ पे लिखा जाता है क्योंकि एक बार हमें किसी भी नोबल गैस का इलेक्ट्रॉन क्या है, इलेक्ट्रॉनिक कॉन्फ़िगरेशन क्या है, यू कैन से NH2 NP6. दिस इज द जनरल इलेक्ट्रॉनिक कॉन्फ़िगरेशन ऑफ एनी ऑफ दिस नोबल गैसेस. किसी भी नोबल गैस, हाँ n का वैल्यू बदलेगा 2 3 4 5 6 आता जाएगा, लेकिन s होना ही होना है. दैट्स व्हाई दे आर कॉल्ड द नोबल गैसेस. तो 6 और 2 8 ऑक्टेट कंप्लीट होता है एक्सेप्ट हीलियम. हीलियम एक ऐसा एलिमेंट है जिसके आउटर में दो होते हैं, स्पेशली हम जब नोबल गैस की बात करते हैं तब. एंड दैट्स व्हाई किसी भी इलेक्ट्रॉनिक कॉन्फ़िगरेशन में यहाँ पे आर्गन लिखा जाता है. दिस इज द शॉर्टेस्ट वे. हम लोग एटॉमिक स्ट्रक्चर डिस्कस कर रहे हैं मॉर्निंग में जहाँ पे हम लोग ये बात करेंगे वहां पे. समझ रहे हैं आप लोग? ओके. तो अभी बात ने भी एक सवाल पूछा था कि लैंथम और इनका एफ ब्लॉक एलिमेंट में इलेक्ट्रॉन है, एफ में इलेक्ट्रॉन है, तो दे आर कॉल्ड एफ ब्लॉक एलिमेंट. 100% दे आर कॉल्ड एफ ब्लॉक एलिमेंट. So lanthanum onwards, all the elements whose electron lies, last electron lies in F subcell, they must be called as F block elements. They are called as F block elements. So that is what we can say. So this is the classification of element on S, P, D, and F block elements. That's what we can write it or we have it. ठीक है? तो ये हमारे पास होता है. So that is electronic configuration according to S, P, D, and F block element. Now thing is that इसके अंदर जो सीरीज भी आते हैं, मतलब स्कैंडियम सीरीज को 3D सीरीज, 4D सीरीज, 5D सीरीज एंड 6D सीरीज. सो ये सीरीज आते हैं बिकॉज़ जैसे हम लोग स्कैंडियम के इलेक्ट्रॉनिक कॉन्फ़िगरेशन हमने देखा स्कैंडियम का, तो दिस इज स्कैंडियम 21 1s2, ये आर्गन की तरह लिखते हैं ना हम शॉर्ट में. सो दिस इज आर्गन जहाँ पे 18 इलेक्ट्रॉन चले जाते हैं. फिर इसके बाद आता है 4s2 और 3d1. सो दैट्स व्हाई देखिए दिस इज द सीरीज मतलब फर्स्ट एलिमेंट इन डी ब्लॉक एलिमेंट. टोटल डी ब्लॉक माने जाते हैं, टोटल डी ब्लॉक माने जाते हैं, जिसमें से पहला एलिमेंट स्कैंडियम है और स्कैंडियम का है 3D सीरीज. तो ये 3D सीरीज है तो उसके नीचे 4D होगा, उसके नीचे 5D होगा, उसके 6D सीरीज होगा. तो एवरी सीरीज कंसिस्ट ऑफ 10 एलिमेंट्स ईच. डी ब्लॉक के अंदर बात करेंगे तो हियर 3D सीरीज, 5D सीरीज. हम जानते हैं ना जैसे डाउन द ग्रुप आते हैं तो एक शेल ऐड होता है. ये हमने देखा है फर्स्ट ग्रुप के अंदर देखा है, इसलिए मैं बता रहा हूं कि फर्स्ट ग्रुप का एलिमेंट इलेक्ट्रॉनिक कॉन्फ़िगरेशन देखिए, थर्ड पीरियड का इलेक्ट्रॉनिक कॉन्फ़िगरेशन देखिए, उसके पूरे पीरियड का अंदाजा आता है. व्हाट हैपेंस डाउन द ग्रुप सेम हैपेंस फॉर ऑल द ग्रुप्स. तो जैसा पोटेशियम के बाद नेक्स्ट में एक सेल ऐड होता है, उसी तरह से 3D के बाद 4D होगा, 5D होगा, 6D होगा. दिस इज द इलेक्ट्रॉनिक कॉन्फ़िगरेशन व्हिच इज एक्सपेक्टेड, व्हिच इज देयर एज इट इज. सो दैट्स व्हाई इसके कारण ही all these elements are called D block elements. Amongst that first period is मतलब this period which is fourth period called as 3D series. यहाँ से लेकर यहाँ तक that starts with scandium, ends with zinc, starts with yttrium, ends with cadmium. Here you can say hafnium, ends with mercury. Then here you can say rutherfordium, ends with uninium. So onwards. हर इसमें 10 elements है उस सीरीज में. So this is called 3D series, 4D series, 5D series, 6D series, और each series consists of 10 elements each. So that is what we can say electronic configuration for this D block elements. And when we come to the P block element, then P block के अंदर when we start right from here, it starts with 3p1 to up to here, it is called 3p6. So P has the capacity P1 to P6. So all these P block element has the electronic configuration P1 to P6. So accordingly we have this here in this P block elements. यहाँ पे हो जाता है. Clear with this? So that is what we can say P block elements. और हर एक ग्रुप का 13 ग्रुप का P1 है, तो उसके बाद का P4 14 का P2 है, P3 है, P4 है, P5 है, P6 है. इस तरीके से वो इलेक्ट्रॉनिक कॉन्फ़िगरेशन आगे आगे चलता है फॉर स्पेशली फॉर द पी ब्लॉक एलिमेंट एंड ये ब्लॉक एलिमेंट हैज अ टू सीरीज. First is the lanthanide series, second is the actinide series, and all this has lanthanide series also called as a 4f series because their electron lies in 4f. लैंथन से 4f होता है, वो आगे ल्यूटेटियम यहाँ का एलिमेंट है, वहां तक चलता है जहाँ पे 4f 14 होगा, क्योंकि हम जानते हैं f has the capacity 1 to 14. तो अभी ये सारे 14 एलिमेंट्स है, वो यहाँ पे एंड हो जाता है f 14 होता है. और ये सीरीज कॉल्ड एज 5f सीरीज बिकॉज इनका इलेक्ट्रॉन, मतलब हम एक्टिनाइड की बात करते हैं तो एक्टिनाइड का लास्ट इलेक्ट्रॉन 5f में आता है. सो 5-1 कहा जाता है. आप इलेक्ट्रॉनिक कॉन्फ़िगरेशन लिखे दिखेगा, एक्टिनाइड 89 एटॉमिक नंबर है उसका, वो लिखे दिखेगा. सो दैट्स व्हाई ये एक्टिनाइड के सारे एलिमेंट्स का इलेक्ट्रॉन 5f में होता है एंड लैंथनाइड के सारे सीरीज के एलिमेंट 4f में होता है. तो इसीलिए यहाँ पे भी दो सीरीज आते हैं. सो पहला सीरीज कहा जाता है 4f सीरीज और दूसरा कहा जाता है 5f सीरीज. सो दिस इज नथिंग बट लैंथनाइड एंड दिस इज नथिंग बट द एक्टिनाइड. तो all elements of lanthanide series has their last electron f4f and all elements of actinide series have their last electron in 5f, and that's why that is called a 4f series and 5f series. There are two series here in this classification of elements. Clear with this? So that is the electronic configuration and classification as SPDF block. And internally the general electronic configuration, there are 4 series 3D 4D 5D series. There are 2 series 4f and 5f series. Each series consists of 14 elements each. Here each series consists of 10 elements each. So that is what we can say electronic configuration based on this block. Clear with this? So that is the things. This is the dynamism which is related with electronic configuration and periodic table. So once again, I will suggest and state those who are not clear with electronic configuration need to invest time in electronic configuration. Try to understand the electronic configuration. Many of the concepts in science or chemistry will become easier with electronic configuration. So please go ahead with this one and let's move. So next topic called as properties of S block elements and P block elements. S, P, D, F block elements. Okay. So next properties of S, P, D, F block elements. So pehla, that is S block. Dusra, that is P block. Tisra, that is D block, and fourth one is F block. F block element. So जैसे अभी हमने periodic table draw किया था, so this is S block element, this is D block, this is P block, and this is, you can say, F block. Okay, ये हम जानते हैं. So अभी देखिए हमारे periodic table के अंदर अभी हमने देखा कि classification is done on this basis. Now what are the some common properties we have for S block? What are the common properties for D block? What are the common properties P block? And what are the common properties of F block? That's what we have discussed here. So when we talk about this common properties of S, P, D and block element, आप already जानते हो. ये सारा टॉपिक हमने 7th 8th 9th 10th में जो डिस्कस किया था उसी का जस्ट फॉर्मुलेशन आता है. नया कुछ भी नहीं है. एक दो चार नए नाम शायद आएंगे लेकिन बाकी सब तो वो सिमिलर उसी तरीके से. So what are called as S block elements? S block किसे कहते हैं और S block के अंदर क्या प्रॉपर्टीज है? S block के अंदर दो ग्रुप आते हैं, ग्रुप फर्स्ट एंड ग्रुप सेकंड. सो S block के अंदर आता है, you can say, ग्रुप फर्स्ट एंड सेकंड. First and second, these two groups are here in S block elements. First group are called as alkali metals or alkali elements, alkaline elements, and alkaline earth metals or alkaline earth elements in second group elements. So first group जो है वो elements कहा जाते हैं alkali elements or alkali metals, and the second group element कहा जाता है alkaline earth metals. So that is what we can see here as block element. और metal has the tendency, metal के बारे में हम अच्छी तरह जानते हैं, metal has the tendency to lose electron. So all the elements in S block element has a tendency to lose electron, form anions, cations. They have the tendency to form cations, and they have low ionization enthalpy. Low ionization enthalpy मतलब कैसा है कि सोडियम की बात करते हैं इस ग्रुप के अंदर, तो सोडियम has the tendency to lose electron to form Na plus 1 electron is lost. This is called as a cation formation. So when we talk about sodium, potassium, all elements present in first group or second group, कैल्शियम की बात करते हैं, पोटेशियम की बात करते हैं, both has the tendency to lose electron. बस first group element has the tendency to lose 1 electron and form cation plus 1, and second group element, say like calcium, has the tendency to form calcium plus to lose 2 electrons. So second group के जो element है, ये मैंने example के तौर पर दिया है. Calcium belongs to second group and sodium belongs to first group. तो just it is sake of example. So कोई भी element from the first group, any element from the first group loses one electron and forms cation with +1 charge. Second group element loses two electrons and forms +2 charge. मतलब both first and second group element has the tendency to form cations with +1 and +2. That is called as your ionizational capacity. And the tendency to form this one when energy is supplied called as ionization potential. आयोनाइज होना और कैटाइंस करने को कहा जाता है आयोनाइजेशन पोटेंशियल व्हिच इज एक्चुअली लो मतलब इनका ऑक्टेट कंप्लीट नहीं होता है इसलिए इजीली इलेक्ट्रॉन छोड़ देते हैं और इलेक्ट्रॉन इजीली छोड़ के वो ऑक्टेट कंप्लीट करते हैं सो दे हैव अ नेचुरल टेंडेंसी टू लूज इलेक्ट्रॉन एंड फॉर्म द आयंस तो ये होता ही उनके अंदर तो इसलिए उन्हें बहुत कम एनर्जी सप्लाई करेंगे तो उनका आयोनाइजेशन हो ही जाता है इवन दैट आयोनाइजेशन एंथैल्पी डिक्रीजेस डाउन द ग्रुप जैसे नीचे आएंगे वो आयोनाइजेशन एंथैल्पी और कम होती है डिक्रीज होती है और ऊपर की तरफ ज्यादा होती है सो दैट इज व्हाट वी कैन से ग्रुप फर्स्ट एंड ग्रुप second S block element. तो S block elements में क्या बारे में क्या देखा हमने first group and second group elements are called as S block elements. Their last added electron present in S subcellular, that's why they are called as S block elements. All these have the tendency to lose electrons and form cations. First group elements form cations with +1 charge. Second group elements form cations with +2 charge. They have low ionational potential, and that ionational potential decreases down the group. All are metal. First group elements are called as alkali metal. Second group elements are alkaline earth metals. So that is what we can say here for S block elements. Now let's go to the P block elements. So these are the P block element. P block element has group 13 to 18. Group 13 to 18 are called, you can say P block elements. Now, when we talk about the P block element, conventionally, traditionally, the classification of elements can be done as metals, non-metals, and metalloids. Metals, non-metals, and metalloids. So P block element has the combination of metals, non-metals, and metalloids. इसके अंदर जो देखते हैं सारे metals है, but यहाँ पे देखते हैं तो इसके अंदर metals इस तरफ है, non-metals इस तरफ है और बीच में metalloids है. P block की और एक खासियत है, P block के अंदर आपको 18 ग्रुप मिलता है जो यहाँ पे दिया गया है, जो मैंने आपको बताया था आपको 18 ग्रुप एलिमेंट, जिन्हें हम लोग नोबल गैस कहते हैं, नोबल गैसेस कहते हैं या फिर इनर्ट गैसेस भी कहते हैं. बल्कि यहाँ का जो ग्रुप है दैट इज कॉल्ड एज कैन से हैलोजेंस. मतलब ये जो है ग्रुप 17 है, ग्रुप 18 और यहाँ पे जो दिखता है ग्रुप 16, देन 15, 14 एंड 13. सो लाइक दिस ये होता है. सो group 18 elements are called as noble gases. Noble gases are also called as inert gases. Group 17 elements are called as halogens. Fluorine, chlorine, bromine, iodine, all these elements are called as halogens because halos means sea salt forming elements. So these elements has the tendency to form sea salt, sodium chloride, potassium chloride, sodium bromide, potassium bromide, like this, all these, sodium iodide, etc. So all these elements has this sea salt forming capacity. That's why they are known as halogens. Whereas this oxygen family group elements 16 are called as chalcogens. उन्हें chalcogens कहा जाता है. तो हर एक का अपना नाम भी आता है. These are noble gases, these are halogens, these are chalcogens. इस तरीके से उनके नाम आते हैं. तीन फैमिली भी P ब्लॉक के अंदर आते हैं. P ब्लॉक के अंदर मेटल्स, नॉन मेटल्स, मेटलॉइड इस तरीके का भी क्लासिफिकेशन उनके अंदर आपको मिलता है. नोबल गैसेस की खासियत हम अच्छी तरह जानते हैं और मतलब दे हैव कंप्लीटेड डुप्लेट और ऑक्टेट. और halogens के बारे में हम जानते हैं, they have valence -1 or they have valence -2. This classification is also often or observed in case of these elements. So that is, you can say, properties of P block elements. Let's move to the properties of D block elements. So D block elements are here, we can say. So these are the D block elements, and we have to discuss what are the properties of D block elements. D block elements are, the D block element consists of group 3 to group 12. So the group 3 to group 12 elements are called as D block elements because their last electron occurs in D subset. It has 3 series, 3D, 4D, 5D, 6D series. That is what we are saying. All these elements are called as transition metals. All these elements are called as transition metals because they have the properties of these metals and non-metals. Right from this one, when we move from left to right towards this here in this period. So these are the purely metals. They shows the purely metallic property. They shows metals, non-metals, and metalloid properties. They have the properties into the transition. That's why they are called transition metals. So again, in a transition metals, these are the metals which gives the color because they are empty d orbital, and also because of which they show some of the properties as like even color formation. D block elements के बारे में और एक है, because of empty d orbital, they also acts as a catalyst. So many of the elements you can see in the organic chemistry, there are many catalysts you write on the head of the arrow for the reaction. Nickel, cadmium, copper, all these are acting as a catalyst, and these are nothing but the D block element. So D block element has the catalytic property. This shows the catalytic property. They shows the color property. Even color all here in this world, color all here in the nature are due to this D block element. They are mostly responsible for the colors in this world. दुनिया में जो कलर है वो डी ब्लॉक के कारण ही है. So that what we can say about D block. इसके अंदर ये भी आता है कि zinc, cadmium and mercury, these are the three elements whose d orbital is completely filled, and that's why these are the exceptional elements which are not called as D block elements. Zinc, mercury and cadmium, these are the elements are exceptional. They are not called as D block element because their D block is completely filled, and that's why they have some different properties as compared to the D block elements. So they are also called as, based on the electronic configuration, they are not D block elements. ये भी उसके अंदर की खासियत बात है D block के बारे में. Hope so you don't got D block elements. D block elements consist of group 13 to 12. It has 3 series, 3D, 4D, 5D, 6D series. It has 40 elements because each series consists of 10 elements. These elements has the properties of in between metals and non-metals. That's why they are called transition metals. They have electronic configuration that is ns2, n-1, d1 to 10. मतलब d generally होगा वो n-1 होता है, n-1 d to 10. So you can say ns2, n-1, d1 to 10. This is the n-1 d है ना. So यहाँ पे होगा ns2 and n-1 d1 to 10. This is the electronic configuration for this D block element. The general electronic configuration for these D block elements. They have the properties transition into this one. They also have the catalytic properties. वगैरह वगैरह हमने उसके अंदर discuss किया हुआ है. And lastly, towards this, nothing but here. F block elements. A block elements are here. These are deeply colored metals. All are the metals. Even these consist of some radioactive elements. There are some of the elements here in this series. After the uranium are called a trans-uranium element because they are artificially prepared in the laboratory. Most of the element after uranium 92, uranium which has the atomic number 92, are made artificially in the laboratory. That's why they are called a trans-uranium elements or man-made. That is that's the element over here. This A block has 2 series, 4F series and 5 series. Each series consists of 14 elements each. Their electronic configuration is, you can say, Na2, n-1, d0 to 1, and n-2, f1 to 40. This is the general electronic configuration for these A block elements. And that's why they are called these are called inner transition metals. They are called here, you can say this is A block elements, and mostly are the metals. They consist of even some radioactive elements. That is what we can say F block elements. Clear with this? So these are the properties of this S, P, D, and F block element. तो पहले हमने classification of the elements on the basis of block देखा. यहाँ पर हमने देखा their common properties. S block, P block, D block और F block के कुछ common properties क्या है वो हमने यहाँ तक देखा. Clear with this? So that's it, and then tomorrow we are turning towards trends in periodic properties. Till then, bye bye. Thank you very much. See you tomorrow.